In this video, we will be going through the new rubric in detail and rating an engineering design project as we go. The sample project is titled The Best Maglev Train. It is important to note that the new rubric has not changed any of the requirements for a science topic. It just adds new information about engineering topics so that they can be judged fairly. These additions have been made in order to be more inclusive of engineering projects, as this is extremely important in the New York State Science Learning Standards. Originality of question. The point of this section is to ensure that the same old project doesn't win every year. To get the most points in the category, projects should stem from original ideas or different perspective on traditional ideas. If a judge has seen the experiment before, that project will get few or no points in this category. However, a good project that is not quite original can still do very well by earning high scores in all other categories. For our sample maglev engineering project, the question is about which maglev train design is the fastest. This project will likely get low points for originality because judges have seen this topic many times before, but it still has a chance at an overall high score as long as the remaining criteria receive high scores. Hypothesis, define the problem. This section tells a judge what the student would like to find out or investigate and what they think will happen and why. For an engineering project, this would include what the student will be designing and testing, and which design they think will be the best, and why. The best hypotheses include a statement about what result the student thinks he or she will get along with the question to be answered. This is very often structured as an I think, because statement, but does not need to be in this exact format. For our sample maglev engineering project, the hypothesis is the train with the most curves will be the fastest because it will have less air resistance, and would score high points because it included a because statement explaining the student's reasoning behind the hypothesis. Procedures or engineering design solutions. This is where a student explains the process for executing the experiment or testing their design. It is easiest for a judge to read this section if it is written step by step. For a science project, this must follow the scientific method, and for an engineering project, this must follow the engineering design process. The design process includes the following steps. Identify a need or problem, research and brainstorm possible solutions, choose a solution, design a solution, test and evaluate. If there was any adult help needed in the project, this should be mentioned in the procedures so that it is obvious that the child did the experiment or designing alone but had help with some parts. In our sample project, the student stated that, I could not cut the wood to make it, so my dad did that. This shows that the student found a design but could not build it alone. It is okay for adults to support parts of the project, but it should always be obvious to the judges that the student did most of the work. The best projects also have a detailed journal in which the student wrote what they did each day for the experiment. Judges love to see the thought process of the student, and it helps them to better rate the project. For our sample project, the process could have included more specific details, such as more about how the train was made or exactly what kind of materials were used. In addition, there was no journal for our project. Therefore, our project would get some but not all of the points in this category. Investigation trials. For science projects, students must repeat their experiment at least 3 times. In the case of engineering projects, if it is not possible to repeat the test, like in the case of testing bridge designs, once you test the strength of the bridge, it is broken and cannot be tested again, the test can only be done once for each design, as long as there are at least 3 designs being tested. However, if there is only one design being tested, the test must be repeated at least 3 times. In our sample project, the student repeated the test multiple times to get an average value, which helped with providing a better conclusion, but was not necessary to gain all of the points in the investigation trials category. Therefore, the sample project would get full points for this, as there were 3 different designs tested. Analysis. Data should be presented clearly in tables, charts, or graphs so that it can easily be read by a judge. These graphics must also make it obvious to a judge that the student repeated the experiment enough times. It is also important that the data relates back to the hypothesis, question, or problem. If there is well-organized data, but it does not provide information needed to answer the question listed on the project, points will be lost in this category. The data section of our sample project would get a high score because the data table was organized, easy to read, and clearly shows which train is the fastest. Evaluation, conclusion, or solution. Along with the data, there should be a conclusion in which the student relates their findings to the original hypothesis or question. Also keep in mind that the best projects have a conclusion that relates to a real-world application and raises new questions about the topic. Our sample project would get a high score for the conclusion because it refers to the hypothesis, gives a reason for the results, and talks about real-world applications. However, it does not raise new questions, so it would not earn all of the points in this category. Presentation. This section of the rubric is where judges rank the overall presentation or look of a project. This does not mean that the project must be typed and perfect. In fact, judges like to be able to see that a child did the work, but if the project is handwritten, it should look like the student took their time to try and make it look nice. In our sample project, the presentation is very easy to follow, and the student clearly took time to organize the information, so it would get most or all of the points in this category. Common reasons for not winning. The student's face, name, or school name is visible somewhere on the project. The projects must remain anonymous, so do not include any identifiable information. In addition, if you have photos on your project, we recommend that you label who is in the photo so that it is obvious that it is not the student who created the project. Not enough trials. Make sure to complete the experiment at least 3 times for a science project or to test at least 3 different design solutions for an engineering project. The hypothesis has no explanation of why the student thinks something will happen. Also note that a hypothesis does not need to be correct to win. Sometimes the best learning happens when you get unexpected results, and that is fine as long as the explanation in the conclusion addresses why the hypothesis was incorrect. The scientific method or engineering design process was not followed. Sometimes judges encounter projects that are research projects that explain a topic, but no experiment was done or no design was created. These projects cannot be properly judged and therefore cannot win the science fair. Finally, the number one reason for not winning the science fair is the competition. There are many awesome projects submitted by young scientists, and remember, each of you has already won your school science fair. That is why all participants leave with a ribbon and certificate for their achievements. If you have any questions, please do not hesitate to contact us at sciencefair@bnl.gov. Thank you.